Alright, so the last video I showed you how to graph the natural log of x. Today I'm going to show you the translation pattern that basically allows us to horizontally and vertically translate any logarithmic function. The overall algorithm in which you are going to translate any logarithmic function is equal to log base a of x plus or minus h plus or minus b. Now, this also means that you have the same thing as log of x plus or minus h plus or minus b, or the natural log of x plus or minus h plus or minus v. This one's for any numerical base. This one's for base 10. So number base A. This is base 10. This is obviously base E. Now, essentially, you can move it the same way as you did with the exponentials, right? Okay? Except this time, all vertical asymptotes are going to move with this. You would think, right? This is for exponentials. Exponentials moves up and down. We don't care how it moves up and down. What really matters and changes the overall domain is these values. The horizontals. So the vertical, and it makes sense, the vertical asymptotes move with however you move your function horizontally. So vertical asymptotes move with x plus or minus h. Okay? So, for instance, if I have f of x equals the natural log of x plus 1, I know right off the bat it moves left. It moves left horizontally. Horizontal translation, 1 unit. Okay? Now, what that would mean is I have a vertical asymptote at x equals -1. So I draw a horizontal, or not horizontal, but vertical asymptote at x equals -1. Okay, so x equals -1. Well, then from that point on, you draw a table of graphs, you draw a table of values, and you start plugging stuff in. Well, you're not going to plug in anything at -1, but you can plug in at 0. You can do E. Let's do E, and let's do let's do E squared. Okay. So if I plug in -1, I'm going to get error. If I plug in 0, I'm going to get the natural log of 0 plus 1, which is equal to the natural log of 1, which anything to the 0 power is 1, so it's 0. If I do the natural log of e plus 1, that's just a number, and that is basically at e. And if I get the natural log of e squared, I'm going to do the natural log of e squared plus 1. So at, I'm going to do, I'm going to do e, and I'm going to do e squared. So at 0, I'm going to have natural log of 1, and anything to the e power, so that's going to be right there. At e, I'm going to have natural log of e plus 1, so it's probably right there. That's the natural log of e plus 1. Some number, right? Well, that's going to be right there. And then I have another number over here, which is the natural log of e squared plus 1. Well, that's going to be right here. So if you look at it, it's going to be a natural log. Okay, and it's literally that easy. So this is obviously, basically just by looking at that, we see that it moved to the left 1 unit. Well, at which point, if I move it up or down, it's not going to really matter. What really matters for the vertical asymptote is vertical asymptotes move with whatever happens horizontally. So I really have to look at what's inside the parentheses for the vertical translation. So that would be a translation pattern and a translation example for the natural log of x plus 1. The next videos I will upload will be less about this and will be focused more on solving exponential functions and logarithmic functions. And that will pretty much cover the entire exponential and logarithmic function unit. So I'm going to figure out a way how to upload these tonight and give you access to them. And hopefully these videos can be of benefit to the future. So have a nice night.